as we work through this, let's get through this here. This is the end of 1.2. This is part 2. We're doing a couple of examples here. We have 4 examples total up to example 8, so I guess 5 if you count 4. But the thing I want to kind of elaborate on yesterday, because I know yesterday was somewhat confusing. We were starting to get to some new stuff. I asked some great questions. I will say that the reason sometimes that I kind of stumble in what I say is because, well, I mean, first off, I'm going to make mistakes too because calculus is hard. 2, because you're going to see like some units are going to make our life easier than what we're doing now, but we're doing this now so we know this concept, and then we're going to use something to make it easier later. And so that will happen with derivatives, for example. You'll see what derivatives kind of makes you say, why do we do limits? Okay, and those type of things, because derivatives will help us with limits, all right? But anyway, when we get to this here, so limit of x goes to 4. So we left off yesterday by doing the simple limits of, oh, we can plug it in, that's what it is, we're done. No problem. Now we're into the ones we can't plug in. We cannot plug in 4 because 4 minus 4 is 0 on the bottom, and we have an issue. Okay, so this is where you have to use your factoring skills and your simplifying skills. So hopefully you see on the top that it does simplify or factor down to x plus 4, x minus 4. Okay. We're good with that? And then that's just a nice, simple, pretty neat. That's gone. And now we're going to take the limit as x goes to 4 of x plus 4. So your answer is 8. Is this limit continuous at 4, yes or no? Is this limit continuous at 4, yes or no? No, it is not. We talked about that yesterday. It was in the definition. If you cancel something, that means that you're going to have an open dot there. So it's going to be an open dot there because that's a hole. Because if I put in 4, I have a problem. So remember, you immediately, you know, right away, the fact that we couldn't plug it in right away, it's not continuous. We had to break it down and solve from there. So right away, you know that's not continuous. As the definition said yesterday about continuous. Any questions on that? That's pretty simple, not too bad there. Right. If you can plug in right away that it is continuous, you don't have any problems. Okay. All right, so that's 8, no problem. Okay, so moving forward here, we're going to get to a little harder stuff. Okay, so this is one of those difference of cubes. So you will be given this formula. You do not have to memorize it. Okay, it was on your homework sheet for that one problem. So I'll write it down here. A cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So that's for the top. So this right here factors down to x minus 2, because a is 2. 2 cubes 8, times x squared plus 2x plus 4. If we do substitute, you're saying, why didn't you try to substitute first? Well, I didn't try to substitute first because, 2 squared is 4. What's negative 3 times 2? Negative 6. What's 2 minus 6? Negative 2. Don't all say it too loud. Plus 2 is 0. So it gets you 0 still. We still get a 0. We also get a 0 on top. So we get 0 over 0, which is a problem. Okay, we can't do that either. Okay, it's meaningless, they say. Okay. So that's what this was, and we'll factor this down. Factor the 2 to get you 3 is x minus 2, x minus 1. So you see we're in better shape now, because our issue, our point of discontinuity of 2 is now solved for. Okay, any questions? Okay, so we just go nice. Now we plug the 2 in. 2 minus 1 is 1, so that's nice. That's just nothing really on the bottom. It's just a 1. 2 squared is 4. 2 times 2 is 4, plus 4. Answer is 12. Any questions on that one? Okay, we're going to get a bit messier. Yeah.
Just to clarify, like that 12, when we were making those charts yesterday,
Yeah.
that would be the number like we were approaching.
Correct. 12 is what we're approaching. Correct. And that's what I want to say too, Booker, because you said that. So when they talked about the slope, that's going to be more on the derivative track, and it's kind of because you know how I talked about each point's going to have a different slope. So when we plug in a specific number, which when we did 1, 1, that's a specific number, it gave us a specific slope. This is to the graph itself, what it's doing at this juncture. So we're not looking for the slope at this point. We're asking, was it doing at that spot? Okay, so it's a little bit different in terms of the slope stuff, but yes. Okay, so this one. Okay, now we're getting uglier. So this is where you guys have to get really good at, like, kind of when I was talking to Kita about the pre-calc review. Yeah, you can GCF stuff. Can I factor it? It looks different, but can I still do it? So kind of that higher factoring that we did in Math 20, if you kind of have that sense, those things can help you. You don't need it in this one, but you're going to need it in the next one. So I'm going to work you through this one. So again, we know this has a problem. I can't plug in 0. You're saying, well, factor it. Well, how would I factor this? Because what's the real problem? I want h to go away, right? So factoring this really doesn't help me right now, so I'm going to FOIL this out and see what happens. So when I FOIL this out, it's going to give me, so if you do 2 plus h times 2 plus h, you're going to get 4 plus 4h plus h squared minus 4. Does anybody have the aha, that's why that helps? Does anybody see why that helps? Well, yeah, when can we, Molly? There we go. The 4s are gone. These both have an h out, so I can take an h out. So it's going to be 4h plus h squared all over h. Pull the h out. H times 4 plus h. Sweet. That's what we're trying to do. And now I can evaluate that limit. Four plus 0 is 4. Okay, questions there? Not too bad. Okay, now we're going to get uglier. All right. So I'm going to kind of let the video play here while I'm recording, but I want you to tell me, what would you try without me just telling you, because again, I know what I'm doing. What would you try to do here? Because the problem is we need to get the x off the bottom, but how? Square the radical? That'd be nice. You're on the right track, but we can't just square things. Because, hold on, I want to make a point here to what Zach just said. And yes, conjugate's correct, Zach. Okay, if I just square things, I can't just square, square, square. That's not how the property works. I have to square the top and the bottom. If I square the top, I still have a radical, because I'm going to have the middle, right? That's why the conjugate comes into play, where Zach's exactly right. I want to do the conjugate to the top and the bottom. Okay, whoops. Because the real issue, Okay, the real issue is x can't be, we can't put 0 in for x. I'm okay putting 0 in here, aren't I? That's fine. Okay, so watch. Second thing, sorry. We're doing the conjugate to mess with the top, right? Not the bottom. Does that make sense? So do not distribute until after you do this one. Do this one first, see what it looks like, and then you can distribute the bottom if you need to, because you can save yourself a step. Okay? Because if you distribute both, you might not need it to. Okay? I'll show you what I mean. So root x plus 1 times root x plus 1 is simply x plus 1. We know there's no middle. Are you okay with that? Do I need to explain that? There's no middle. That's why it's a conjugate. -1. That's nice. Plus 1 minus 1. I just have an x on top now. Well, that's great. Oh, so now, since this is sitting here, I don't want to distribute it in because, bam. And I'm a lot happier now. Okay? Tell me, stuff's kind of like puzzles. It's fun. Okay? So limit x goes to 0. So nothing's on top, so it's a 1. And I'll stop here before we plug it in, and I'll see if there's any questions. Everybody with me? Did I lose anyone? We're okay? So you plug 0 in. 0 plus 1 is 1. Root of 1 is 1. 1 plus 1 is 2. Your answer is 1 over 2. Is that limit. Okay, and this next one might help Booker with what we're talking about earlier. Any questions? Okay, last one. I do want to see some good work today, so I'm glad it's short and sweet today. Okay, show that limit of x approaches 0 for 1 over x does not exist. So this is why it doesn't exist. Okay, well, one, I can't do anything to manipulate this. You're like, I can't do conjugate. There's nothing I can do to get that x off the bottom. It's in its simplest state, you can say. This is in its simplest state. There's no more simplifying. I can't, times x to top and bottom doesn't help me because I still have the x in the bottom. There's nothing I can do. Okay? So, looking at the picture, why does that make sense? Why does the limit not exist? Remember, the limit is, what is it approaching at x equals 0? Say that again? You're close. Think about more what the graph's doing, not the asymptote, though. You got half of it. So approaching 0 is from both sides, right? So if I approach 0 from here, it's doing two different things. It's going up and going down. So it's not approaching anything. These are approaching something, right? These are going negative infinity. These are going positive infinity. So as you're approaching 0, it's splitting in opposite directions. So therefore, it doesn't have a limit because it's going in opposite directions. We can't define the limit if it's going in two ways. Okay, so 1 over x is a does not exist limit. So that happens if you can't break it down, if you can't put that in there. Okay, we can't go anywhere. 1 over 0 does not exist itself, so that makes sense. Okay. Any questions on that? Sure. So limit is it's x approaches 0, right? And that's going to be from all directions. This right here is where x is 0. So as we approach x from this way, our graph is going down. As we approach x from this way, it's going up. So it's going two different directions from two different sides, so it's not approaching a single value. Now, what do you mean by value? Well, this is like a bunch of big numbers. This is like 1 million, 2 million. This is like negative 2 million. So it's not consistently approaching the same value, therefore a limit does not exist, because it's going in two different directions. Okay? Yeah, it's because they're going in opposite directions.
So any graph that's like that where they're going complete opposites, it doesn't exist?
Right, because on some of the...
X is 0, is it for?
Say that again?
Is it only for x is equal to 0?
For this case, yes, but it's more of one like this. They gave you an easy one of saying this right here, I can't do anything with that to like change it. It's in its simplest form. So I can't put 0 in anywhere and make it actually exist because 1 over 0 doesn't exist either. So the actual limit doesn't exist, but I'm trying to show you in the picture the reason it doesn't exist is because at that spot, it's going in different directions. So how would you define something that has two answers? Yeah, I can look for one. There might be one in the note, like the practice work today. Okay. All right. Anything else? Okay. So we have, you guys have about 45, 30 minutes. So go right to the book. So there's a couple books. Try to have one book per table.